Talk about JPA. So as I mentioned last week when we talked about the concept of JPA, was that this is one of several implementations of the concept of the object relational mapping design pattern, right, or architecture, where we want to be able to manipulate the database at the object level as opposed to having to deal with the nitty-gritty of a particular vendor or a particular relational database. So JPA is Java's implementation. If you go to other frameworks, they will have their own ways of implementing an object relational mapping, but it's the same idea, right? So somehow you manipulate objects, you create new instances of objects, and you want them to magically be inserted into a database. So we already have a project already running, and we have also configured application.properties last week. I believe here in the resources, pointing to a local database, CS5200 summer 2018 JPA. And we also had implemented user-related services and data models. So we won't work on that. We focus on the user. And that user, we created a data model for that had a username, password, first name, last name. We declared it as an entity, right? And then also configured that particular class to have a primary key called ID. Now, normally in a Java data model, you wouldn't declare these primary keys, right? This is because a Java class, when you create an instance of an object in memory, the object already has an identity, right? It lives in a particular memory space, right? It has an address in RAM. Yeah, so it already has an identity. The fact that we're declaring an ID here is because we are bridging the gap between how you represent this in memory and how it's representing in a database, right? So this is an added field that you typically would not use in object orientation. It's only here because we know that this is going to be represented in some relational database. Okay, there will be a field in some table that will store this ID. We also are also annotating this as an entity, meaning that there will be some table that is storing records for this particular class. So for each instance that we instantiate in memory for this user, there will be some row that exists in the database. Obviously, we're only ever going to have a subset, right, a small subset of the actual number of users in memory. You might have thousands of users in memory in the database, yes, but you will only ever have just a small fraction of whatever is in the database, instantiated in memory. So we are annotating this to be the primary key, and that's going to be auto-incremented. Okay? And I believe we did this last week. Here we have a primary plus any other fields and setters and getters would go here as well. By default, the name of the table, by default the name of the table is based on the name of the class. We can override that. We can say, well, no, I want to map to a particular table name. Right, and we'll see how to do that in a minute. But by default, the class name is used as the name of the table, and by default, the name of the field is the name of the property in the class is used as the name of the field in the table as well. There's a little bit difference on if you have if these fields are camel cased, if it's a long compound word. In Java, you typically you camel case it, right? Every word is capitalized. On JPA, if you configure this attribute here, it will instead substitute all those capitalized words. It'll substitute with underscores, right? And then all lowercase, right? Otherwise, if you don't configure this, it will just lowercase everything. Right? Even though in Java you're following some naming convention, it will just lowercase everything, right? Because in SQL typically is case insensitive, So it doesn't really matter if you camel case everything in SQL, it will just lowercase it or uppercase it. But here, it goes a little further, and it modifies it and gives it an underscore. At least it makes it easier to read. Okay? Let's see. We also talked about last week that the entry point of actually talking to the database is what is referred to as a repository. Right? It's the object that gives us a generic API to be able to insert, find, update, delete these objects from the database. It needs to be configured to know what is it that you're storing, what is it that you're finding, what is it that you're updating. And here we're extending already a boilerplate implementation that already implements the most common CRUD operations, right? Being able to find all, find by ID, update, delete, delete by ID. So lots and lots of really nice functions in there that allows you to insert or update or delete or find users. The other configuration here is that you need to tell the type of the primary key. The primary key it's not always going to be an integer. Sometimes it could be a varchar. It could be a compound key, right? That has maybe a couple of made up of multiple keys, right? And if so, you would have to have a class, a Java class, that would have all those fields, right? So if you had, my key is my first name, last name, and social security number, or whatever, I don't know, the combination of those three fields, I would have to have a class that would contain all those three fields, right? And then that would be the type that would go in here. Here we're using a simple primary key. It's just an integer. This is the table that gets generated, and this is, I believe, this is what we covered last week. Let's see. This I believe we had inserted. Where is it? Oh, here it is. Yeah, this is the user that we looked at. We implemented last week. First name, last name, password, and username. We also implemented the RESTful API for this. Right? We had inserted a couple of folks in there, and we were able to expose all the lists of users. I'm just going over last week. Find all users, or find a particular user, or find by some other field or some other criteria that is not based on the primary key. For instance, by username, or by username and password, or by salary, or by role, or by any other field or combination of fields that you have a custom query. And we had mentioned that to do that, we would have to implement our own finder functions. Yes? I think last week we implemented find by credentials, I believe. Let's see. No, that's not it. We had implemented in user repository. Yeah, we had created this find by username. Okay, so it's the same one we have there. Right, and we had introduced to you the syntax, this new syntax of this query that it's pseudo SQL. It looks like SQL, but it's not. Right, it's an object-oriented SQL called JPQL, so Java Persistence Query Language, where this is not a table. It's actually it's referring to the class name. The class is called user. The table happens to be also called user. And the syntax is actually nice because it looks very much like SQL. In SQL, you can have user a very similar query syntax where you have user, that's the name of the table, and then an alias, right? And then the alias. But here, actually, it's declaring a variable. Find me all the user instances of type user. Okay, so select all the users where, and this is the criteria, where the user dot username is equal to you. So it's very, very similar to, they made an effort to make it as close as possible to what SQL might look like. So that if you know SQL, you should find yourself right at home, right, with JPQL. Okay? But again, it's object oriented as opposed to flat SQL. All right, so we once we had that, we could go on and implement a couple of endpoints to retrieve a particular user. So this was for retrieving all the users using the find. Okay, now this one was trying to implement the fact that you can either retrieve all the users or you can pass as a query find a user by its username. So here it's checking to see if you did pass a query, a username query. If it is, then we found that user by username. Otherwise, we retrieved all the users. And I believe that's what we implemented last week in the service. Find user. Yeah, exactly. Find user, find all, or find by username, by username. We went around it, but almost the same what we did last week. There was another example where if you're trying to log in, useful for logging in, and you want to be able to find a particular user by credentials, you could create another query, another finder method that did a select and use the username and password to retrieve that particular user. I don't know if we have any other users. Yeah, we have usernames for both, user and password for all of them. Let's implement it. Let's grab this, and if we go to our repository, we can declare it right there. Let's see. There we go. There's our query, and it's returning. Let's see. Do we have a? I don't think we need that. I think we just need that, and we don't need that. Okay. We can restart the server. And then we can expose this. We can expose this in the same service that we're using earlier. Here in the service, we could ask if we have both username and password. And I think I have it here. There we go. All right, so let me just copy this, right? I find all users, and we are retrieving both the username and password. So find all users. There it is. Find all users. This one is retrieving the username, but if we can add just as much, we can add also the password. There's the username, and then we can add another request parameter that retrieves the password. Right. So this could be several if statements, right? This could say, if if I have both username and if username is not null, and I also have the password. Then I can just else if. So if I have both username and password, then I can use my new finder method that I just created. I can say then return user repository dot find user by credentials and pass in the username and password. Right, and probably I'll need to cast it to list user. Otherwise, if I have only the username, then why did I write it that way? That's weird. Right, if it's not null, then do this. Otherwise, just return the user repository dot find all. There we go. And this I need to cast it. Fine, user by credential. What's this returning? Oh, I see. I guess I could return this too, right? And this should be public as well. So public. This would make it easier. And then here we can return this. There we go, like that. All right, yeah, so now I can either pass just a username and it retrieves that particular username. That's useful like for registration, making sure that the user doesn't already exist. And we can notify the server, the client that, oh, sorry, that username is already taken. Or for login, right, if you provide both username and password. Although if you're logging in, usually you don't provide them in as part of a get. Typically you would provide it as a part of a post. Right? But nevertheless, this is a good example. So if that's, probably we need to restart the server. And let's see if we have that running. So we have a user. Is the server running? Not yet. Oh, so there we have all the users, or we can filter and say that we just want Wonder Woman there. Or that I want both. I can provide the username and also the password. So we can say and the password is equal to 123. So it's that particular person, right? Or if I got the password wrong, right, it doesn't return anybody, right? And again, this is useful for logging in, for registration. Although again, you would never pass a password as part of a get in clear text. Typically, you would instead pass it in a post, right, and probably encrypt the whole thing until it gets with SSL on the other side. All right, so let's see what else. Let's keep going here. So that's a user. All right, so we had worked on retrieving data. I'm not sure that we had worked on creating data. Let's see. All right, so we have a post. Did we ever play around with posts? I don't remember. I don't believe so. Creating new users. We would have to do a postman. Probably. Did we create a postman last week? Let's see. Yes, we did. I remember. Yes, we did do a postman. Yes, maybe. Oop. Cancel. Did we? No, it doesn't look like it. Create. All right, so let's try it out. Let's see. We did create a post. So this says it's mapped to /user, and it's expecting something that is configured. That has this structure, right? Username, a password, first name, last name. So from Postman you can generate a post. You can point to the API that we want to send the post to. The headers are, let's see, what headers do we have? All right, we have application JSON. You know what? Let's create a brand new one. A new request. Request name. So create a new user. Let's see, 5200. Save to 5200. Very good. Okay. Create a new user. All right. So we're going to post to where are we going to post? We're going to post to let's see, right here. We're going to post to this, right? And there it is, HTTP 8080 user. And the header is that we'll only probably need just a content type. Letting you know that it's application JSON, and the body is going to be just username. let's see. This needs to be proper JSON. It does not. It doesn't like it when you do a shortcut. So username. Let's see. What usernames do we already have in there? We already have Alice, Bob Dylan, C, D, A, B, C, D, E. Somehow we skipped E. So the username is maybe Ed. Password. Maybe Ed123. And first name, Edward. Last name, Scissorhands. So yeah, so let's post this. Let's send that. And notice that it came back. It echoed back the information we just sent it. Plus the ID, unique identifier, and we can verify that indeed it made it to the database by querying, and Edward is in there. Okay, excellent. So we did do post last week. Let's skip over that. Post RESTful, update user is a little bit different. The way JPA works is that to update something that already exists, you first need to find it. You need to go and retrieve it from the database. Once you have it in memory, that object is considered to be a managed object. Right? It's an object that it's not just a plain old Java object. It's an object that is tied to the database. Whatever you are doing to that object, the ORM is keeping track of any changes, right, to make sure that whether the object is clean, meaning it's pristine, that nothing has changed its state, that the state hasn't changed in memory. But if the state has changed, it keeps track of what changed, because it wants to go back to the database and just update only those fields that have changed. Right? It doesn't want to do a blanket update of all the fields. So it might be a fairly complex object. So I'm not sure. I don't believe we implemented update, did we? Let's see on the repository, on the user service. Did we do a put? We did not do a put. Okay, so let's implement it. So for the RESTful API that we introduced last week, we had mentioned that that we would use post to create, get to read, delete, obviously to remove, and put. We would use it for update, updating something that already exists. So let's implement that. Notice that we're using put mapping, which we're going to import, and we're putting to the API to the user web service here endpoint, and we're providing as an argument the ID of the user that we want to modify. Also notice that we have prepended in front of all our endpoints the /API. We also mentioned last week, I believe, that oftentimes the server is hosting multiple types of resources. Right? It's hosting static content such as HTML, CSS, JavaScript, images, all sorts of documents, and those are considered to be static. Right? It's just ASCII, just files, real files on the file system. Whereas here, these URLs are meant for retrieval or creation of data. Right? It's not meant to retrieve any actual file. It's dynamic data that is being retrieved from the database. Yes. So to make the distinction about these URLs, right? So because we're using these URLs. Who knows if there's an actual document called user, right? If there will be an actual document called user, an actual file called user, how would you distinguish whether you want the data of all the users or do you want a file called user? Yes? So to disambiguate the meaning, right, that sometimes you want static content and sometimes you want dynamic data, to distinguish this, we would agree on a common naming convention, right? And it's a common naming convention is to prepend all data access, all data manipulation with the keyword API. Right? Another common one is REST/REST, although that's a little more generic. I'm sorry, that's a little bit too specific. That this is a RESTful API. It might not be RESTful. Okay, this one is RESTful, so it would be okay for us to use REST here. But a more generic one is also useful, /API. All right, so what are we doing here? So we're going to find from the user repository. Notice that we are parsing the user ID from the URL as a path variable and mapping it to ID. So we can do a find by ID. Oh, apparently I wrote those slides using the older JPA library. Okay, so now it's find by ID. There used to be a find one. All right, so here I'm going to provide the ID, and that returns an optional. So let me change the to optional. So we'll call this optional. And here we need to verify that it's not null. It wraps it into this abstraction to handle the fact that this record might actually exist, right? And it used to be that it would just return null. You can check against null. You say, okay, well the object is null. The record must not be in there. But optional is it gives you a little more higher level. Why didn't you not find it? Right? Maybe there was something went wrong. So optional is a much more generic, much more higher level way of checking to see whether something came back, whether the record is there or not. So the API allows you to ask whether the object is actually there. Right? Is there a record for this primary key? If it is, then we would actually want the user. We can retrieve it from optional. You can get, and now we have the object. Now we have the user. Once we have the user, what we'd like to be able to do is actually update it, right? Update it with whatever data came from the client, whatever data they provided. Maybe a new first name, new last name. I should change my name. 4th of July, when I became a U.S. citizen, that was one of my options to change my my name. Yeah, I'm okay. Right. So here you have we have a generic set function here that I don't actually have implemented. I never implemented it. That you can change certain things. For instance, if I want to change my first name, I can say set first name. We can change the set the first name from the new user.getFirstName. All right, so I'm going to read from the first name of my new user, the new data. I'm going to set it my old user. I'm going to set that, and then I'm going to save it. Let's see, what is it complaining about? This method must return. Oh, okay, yeah. So if it's present, I'm going to return the new object, the new user updated, or I'm just going to return null. If I didn't find it, I'm just going to return null. Okay. All right. So we can play around with this a little bit. We can change this to hit this API. We'll probably need to update the service, restart the server. While that's going, let's see, is this it? Can we close other tabs? There we go. No, I don't want to save. No. All right, so let's create user, and let's copy this. Can I copy it? Duplicate. And I'll call it, can I rename it? I can't rename it. Oh, here. I'll call this update user. Update user. So instead of a post, it'll be a put. and we're actually mapped to API/user. We should change all of them. They should all start with /API. Not sure why it didn't last week. It's same. The headers are the same. The I am going to update a particular user, so I would need to provide the ID of that user. So let's say let's change Alice's first name. So the ID is 1. So let's grab that. So it's 1, and the body. We'll change maybe, I'll just change the, I'll just provide only the field that I want to change. So the first name maybe we'll call it Alicia. Let's see. So I hope the server's up and running. I believe so, right? If we refresh. Yes, the users are there. So let's try and send that. All right, so notice that it came back from the server, and it looks like it was successful. And notice that it came back with the first name Alicia. If we hit our service, we'll notice that Alicia has been updated, and the database also, if we select, notice that Alicia has been updated. Right? So yeah, it's a two-step process. Okay. When you're updating, first you have to retrieve it. You find the user. Right, then you manipulate it here in memory, and then you save it back. Okay. Notice that it's the same exact save that you used earlier to create. So it's smart enough to know that this is a insert, whereas this is an update. Okay. So it knows what to, if the object is already there, it's an update. But if it's not there, if it's brand new, then it's an insert. So JPA would know how to do this under the scenes. All right, excellent. So let's keep going. All right, so we did that. Deleting. I thought we had done a delete. Didn't we do a delete? I guess not. All right, so let's implement a delete. So in JPA, it would look something like this. We would receive a delete mapping. The same mapping that we are using for all the other ones, /API/user, but presumably we're deleting something that already exists. Right? So you need to give me the ID of what it is that you are removing, presumably this record that already exists, and map to the public void. We're not going to return anything. And then we're going to delete user, and we're going to parse that user ID from the path. So this will be path variable, and the name is user ID, and this is the int ID. Right? Once we have that, we can just use the repository. We can say user repository, and then notice that it has a nice function. Just to do that, call delete by ID. There it is, delete by ID. And we can provide the ID as an argument. Okay. So we can restart the server, and then we can duplicate this. Let's save this, and we can. Wait, what? Why did I name them both? Update user. This was create user. What? What the? Are you serious? I can't name them separately? Not you, Siri. Okay, well, I was going to, so I guess, should I duplicate again? No. Does this mean they all have the same name? That makes no sense. All right, so I'll have a delete here. And I want to remove a particular user. Let's see, who should we remove? Chuck Norris. No, he'll find me. Charlie Brown. He doesn't mind. So we'll remove Charlie Brown here. So we'll do a delete 5, and that's it. We don't really need a header. We don't need a body. We don't need anything. Just the ID is being sent over. So let's delete, and let's refresh this. And there we go. So Charlie's gone. Sorry, Charlie. All right, excellent. So let's keep going. Again, the delete by ID. Delete by ID. It's the JPA repository allows you to do all these things from the comfort of your object model. Notice what's happening underneath. See that? Underneath, you're going to keep track of the commands that internally the ORM is using. Right? So that's a prepared statement that it's using. Right? So now these queries are fairly simple, but when we get when it needs to join several tables together and you want to verify that the select statement is correct, this comes in handy. Right? You look at it and you can actually copy it and paste it in your on your workbench, right, and validate that it's indeed working. All right, excellent. Let's keep going. All right, so let's take a look at something a little more sophisticated. For instance, let's take a look at inheritance. Right. So for instance, we have a base user, but we have several folks that inherit from this base user. So let's see how we can implement that next.